Hello everyone. My name is Ashlyn from the Deep Knowledge team. Today we're going to talk about natural language processing, NLP. NLP is all about text and speech processing using software. This field initially relied on linguistic rules, but over time, statistical methods were also introduced as the field evolved. In recent years, deep learning has made great strides, solving many complex NLP challenges.
Our aim here is to learn how we can apply deep learning models to NLP projects effectively. But before we dive in, we need to make sure we have some essential prerequisites in place. To make progress in this field, it's crucial to have a solid understanding of machine learning and deep learning. Additionally, you'll need strong skills in Python programming and familiarity with the following libraries. 1. NumPy, for numerical computations. 2. Pandas, for data manipulation and analysis. 3. NLTK and Spacy, for NLP tasks. 4. TensorFlow and PyTorch, for building and training deep learning models. By mastering these tools, we'll be well prepared to tackle the exciting challenges of NLP with deep learning. Let's start by asking a few key questions. What exactly is natural language processing? How can deep learning methods help solve NLP challenges? How can we prepare textual data for modeling? How are neural models capable of sentiment analysis? And how can a model generate captions for an image? These questions will guide us as we explore the fundamentals of NLP and its applications. Let's talk about natural language, the way we humans communicate daily, through speech and writing. Every day, we encounter countless forms of text and language, from signs, menus, and messages to web pages and emails. But speech is our primary communication tool. We talk more than we write, and this is where the need for methods to understand natural language becomes essential. While humans can easily understand language, it's a challenging task for machines. The structures of language are irregular and flexible, making it difficult to describe their rules precisely. Linguistics is the scientific study of language and its components, including grammar, semantics, and phonetics. In classical linguistics, research primarily focused on formulating linguistic rules. However, modeling language requires numerical frameworks, which adds a layer of complexity. Our goal is to discover new insights from textual data using software tools. In the 1990s, the emergence of statistical methods and machine learning opened a new path for addressing the challenges of natural language processing. In recent years, deep learning has made significant impacts in this field. Deep learning models can identify complex features and semantic patterns without the need for extensive linguistic preprocessing. This reduces the reliance on linguistic expertise and lowers both the cost and time of development. There are two important points regarding deep learning in this field. 1. Need for more data. Deep learning requires large datasets for natural language processing. The more data available, the better the models perform. 2. Reduced need for linguistic expertise. Researchers can create powerful models without the need for deep linguistic knowledge. Deep learning plays a significant role in various areas of NLP, including language models such as BERT and GPT, which have a deep understanding of natural texts, machine translation, where neural networks perform accurate and rapid translations between languages, sentiment analysis, which identifies and analyzes emotions within the text, text generation, where new and meaningful texts are created based on given inputs. Although deep learning has been successful in many areas of artificial intelligence, it has particularly yielded tangible results in natural language processing and computer vision. Alright, now that we understand what NLP is and how it relates to deep learning, let's take a look at how we can apply it and what steps we need to take. 1. Identifying problems and challenges. Before diving into the technical aspects, the first crucial step is to identify the specific issues and challenges we want to address using natural language processing. For instance, are we aiming to improve customer service through sentiment analysis of user feedback? Or perhaps we want to develop a more accurate machine translation system? Clearly defining our objectives will guide our approach and determine the direction of our efforts. 2. Text input and data collection. The next step in our NLP journey is gathering raw text data. We can collect data from various sources such as web scraping, which involves extracting information from websites. Additionally, we can use APIs to access structured data or rely on public datasets available for research and development purposes. 3. Text preprocessing. Once we have our data, the next step is to clean and prepare it for analysis. This includes several preprocessing techniques. We start with tokenization, which breaks the text into words or phrases. Lowercasing the text ensures uniformity, and we also remove punctuation and special characters to focus on the meaningful content. Don't forget to eliminate stop words, common words that don't add value to our analysis, and apply lemmatization or stemming to reduce words to their root forms. 4. Text representation. After preprocessing, we need to transform our text into a numerical format that models can understand. There are several techniques for this. The bag of words model counts word frequencies, while TF-IDF takes into account the significance of words across documents. For a more nuanced representation, we can use word embeddings like word2vec or glove, or even advanced models such as BERT or GPT that generate contextual embeddings. 5. Feature selection. In this step, we choose the most relevant features to improve our model's performance. Techniques for feature selection include univariate selection, which evaluates features individually, and recursive feature elimination that iteratively removes less significant features. Principal component analysis, PCA, can also help us reduce dimensionality while retaining variance in our data. 6. Model selection and training. Now it's time to select the appropriate model based on our specific problem and the nature of our data. We have options ranging from traditional models, such as logistic regression support vector machines, to deep learning architectures like LSTM, GRU, or transformer-based models. Training our model involves using a labeled dataset and applying techniques like backpropagation to adjust the model parameters. 7. Model deployment and inference. After training, we need to deploy our model into a production environment where it can be used for real-time predictions. This often involves building APIs to enable interaction with other applications, and we must consider scalability to ensure our model can handle varying loads. 8. Evaluation optimization. To evaluate our model's performance, we use various metrics such as accuracy, which measures the percentage of correctly predicted instances. Precision and recall are crucial for understanding the quality of positive predictions and the model's ability to identify all positive instances. The F1 score, which combines precision and recall, helps us gauge overall performance. Optimization techniques, such as fine-tuning model parameters and employing cross-validation, can enhance our results. 9. Iteration improvements. Finally, based on our evaluation results, we can iterate through the process to make continuous improvements. This may involve refining our data collection methods to gather more data or address imbalances, enhancing our preprocessing techniques, and even revisiting our model architecture to test different approaches for better outcomes. 10. Conclusion. By following these structured steps, we can effectively apply NLP in deep learning to tackle various language processing challenges. Continuous iteration and improvement will help us adapt to new tasks and enhance our model's effectiveness. In the upcoming videos, each of these stages will be thoroughly examined, along with detailed explanations and code implementations. Keep in mind that in the world of technology and science, there is no ultimate solution. Real success lies in continuous learning and adapting to change. Therefore, we must consistently evaluate our models and make improvements based on the outcomes.